Hello everyone, and welcome to the High Integrity Software Conference, commonly known as HIS. I'm Emma Adby, Managing Director of AdaCore UK and part of the conference organising committee, and I'm delighted to be here today to chair this year's event. Some of you may or may not know, but HIS has been running for 6 years now as a physical full-day conference with a double-tracked agenda and exhibition. Due to the current circumstances, this year we are running it in a new virtual format with 3 20-minute keynotes and a panel session, as you can see on the slide here. Today's event theme focuses on continuing innovation in the face of global challenge, and our 3 speakers from industry will present how strategy is being implemented to do this. Now, before I get onto some housekeeping items, I would like to say, on behalf of AdaCore and Altran, a big thank you to all of our ongoing conference supporters and exhibitors, who we very much hope to be bringing together again at a physical event next year. Fingers crossed. You can find all of these companies on the banner on the console page where you're viewing this event, and also on the event website at his-conference.co.uk, where you will also find within the programme tab the agenda for today with full presentation abstracts and speaker bios, as well as a link at the bottom to the full programme from last year's physical event. I would also like to thank the members of our programme committee, including, amongst others, Mike Bennett from Rolls-Royce, Paul Parkinson from Wind River, James Meyer from AdaCore, and Stuart Matthews from Altran. Now for some housekeeping. You can increase the size of the slides area in front of you by clicking on the button to maximise in the top right of the slides window. You can also press F11 on your keyboard to maximise your screen. Pressing that again will bring everything back. You will also see a Q&A box on the right-hand side of your screen. Please submit any questions as they arise during the webinar by typing them into this box, and we will try to cover them as time allows, although some may have to be followed up afterwards by our presenters. During the webinar, if the slides aren't moving in front of you, you may need to refresh your screen by pressing F5. I would also like to highlight a few of the widget buttons along the bottom of your screen. You can open a widget simply by clicking on it and then close it by minimizing, dragging, or resizing it to anywhere on your screen. If you're having technical issues, most importantly, please check the yellow question mark widget at the bottom left, which will direct you to our help pages. There you can test your system, check minimum system requirements, and review the FAQs. If an issue persists, please do submit the problem to us in the Q&A box, as there will be a technical team on hand to answer those queries especially. The far right yellow button is for you to collect your CPD certificate. You can find out more information about this on the IET website. That should be everything you need to know, so without further ado, let's get cracking. And kicking us off as our first speaker for the HIS Conference Virtual Edition is Simon Creak, Chief Project Engineer of Systems and Software and Chief of the Ecosystem Development Process Transformation Project at Rolls-Royce. Simon has worked in the aerospace industry for the past 18 years, working on control systems for GE and Honeywell aero engines in the early part of his career before joining Rolls-Royce Control Systems, where he has held a number of roles, including leading the control system development for the Trent XWB-97 engine. Through his experience, he has gained a broad appreciation for how the processes, development environment, organization, and program management approach all interact to determine the success of control system product development. Simon is currently leading the Rolls-Royce Ecosystem Program, which is redefining the ways in which Rolls-Royce develops control systems, embedding both model-based development and a product lines approach. Over to you, Simon, to present Modernising Control Systems Development in the Aviation Industry.
Thank you, Emma. In my talk today, I'm going to share with you about the journey we are on in Rolls-Royce to modernise the way we develop our control systems for aero engines. I'll talk about why we are changing, how we're approaching innovation to meet our business challenges, and a little bit about the impact COVID has had for us. As I look back upon my career, I can see there have been some clear trends that have been in place where we've had technological advantage of aero engines responding to trends of making them safer, cleaner, and more competitive. And if I look to the future, I see those as trends that will continue. If I look at what's happened with the products that we produce, there has been an evolution of them in response to those trends, but fundamentally we've still had 2-shaft and 3-shaft civil aero engines. And that's been the same where I've worked with Honeywell, with GE, or with Rolls-Royce. And if I look more specifically at the control systems, again through my career, it's been more of an evolution. So we've had digital engine controls for many, many years now. And yes, they have got more complex, and we've had growth of software and engine functionality. We've had growth of health monitoring. But all of those things have fundamentally been evolutions around existing products. But we know that the world is changing, and there are new trends and new forces coming to play in our business. There's lots of talk around digitalization, which is penetrating all aspects of our product life cycle. Electrification, as we drive to cleaner and low carbon technologies. And these are things that Rolls-Royce is actively pursuing, like many other companies across the sector. But we've also had some very significant short-term, hopefully short-term, impacts from COVID. And these big forces are shaping and will shape the future of aviation for some time to come. And in response to this, established companies must innovate in order to be able to respond to the challenges they pose. If we take a look back through the history of past and present companies, we can see that innovation is not in and of itself a guarantee of success. But it's quite clear that where companies fail to innovate, it is a guarantee of failure. So our world is changing, and it's changing rapidly, and we must respond as businesses to be able to adapt and to be able to succeed and thrive in the face of those changes. There are a number of drivers within controls that have caused us to look at modernising the way in which we develop our control systems. Our products becoming increasingly complex, and the need to ensure that we understand the safe nature of them when they're integrated together. Making sure that we're able to retain the best people by having an environment that people want to work in. Being able to deal with a process that delivers a low level of defects. Embracing and being ready for the challenges of electrification and digitalization. Removing variation that doesn't add value to our products. And being able to do this in a way that is affordable by taking advantage of automations and technologies that exist. When we think about innovation, sometimes people can think about that as being about having a lot of original ideas, those single sort of light bulb moments that shift paradigms. But actually, innovation can be a lot more subtle than that. And I think one of the ways that we've been looking at innovation is about identifying how you can get value from linking together ideas that already exist. And this becomes quite a low-risk way, in a sense, of innovating, because you can take approaches that have been proven to work in other contexts and adopt them for use in your own environment. And actually, often it's that integration and the end-to-end life cycle that really adds value, and being able to link those ideas together becomes key. So within Rolls-Royce, we've taken a couple of key ideas shown to work elsewhere. The first one would be around model-based and model-based development. So that really has been at the heart, and we've worked very closely with MathWorks and using their tool set to be able to change the way in which we're developing our control systems. We found that the key for models is how you use them, for what purpose, and to what rigor. And as we know, in our industry, being able to certify our products ultimately becomes key. So the process by which we use those models also becomes an important factor. The other key concept that we've been taking and integrating into this is product lines. So how we reduce variation and reduce repeated work that ultimately adds no value to the product. Product line approach allows us to get our products developed at lower risk quicker. We also know that there are big advances that have been made in development environments. And so we've been taking advantage of those, the likes of Azure DevOps, and working towards building continuous integration pipelines. So none of these ideas we're talking about here are particularly new or novel ideas. They all have proven context in which they've been operating. The innovation for us is about linking them together in our context to deliver the business value. And alongside that is around the way in which we work as well. So we've changed from teams that are very siloed in their nature to moving to working on a Scrum framework where the focus is very much on how do we deliver value to our end customers. And as part of that, we've been seeking to democratize knowledge. What I mean by that is trying to make sure that all the information around our products and around our processes is clearly available to all of our engineers and developers, and that they in turn build deep product and process understanding. And having that context and understanding what we're trying to deliver to our customer then gives them the freedom to decide how to do it and find innovative and better ways of delivering what our customers need. We've found that by using established tool sets like the MathWorks toolset, we're able to integrate together large parts of our process in a way that provides a seamless environment for engineers to work in. So by linking together the requirements, the tests, the modeling, all into the same development environment, provides a much richer place for developers and engineers to work. We recognise that with complex products, some of the real challenges lie around integration. So we've been putting a lot of effort into making sure that the models are used to simulate early and find those defects early. And a key part of that is creating system-level simulations that contain both the plant model and the controller model. And the beauty of these is that these simulations can then be built into continuous integration pipelines so that as developers are adding more functionality to the product, we can constantly be checking and verifying that the core behavior of the system is still being satisfied and met on a continuous basis. COVID-19 has, as we all know, had a very devastating impact on many lives and many livelihoods. But COVID-19 has also acted as a catalyst for change across many different industries. And we're seeing aspects of that within what we're doing within controls as well. One of the hardest parts of what we've been trying to do through modernising the way we develop control systems is changing the way that people think about the work. So sort of cultural changes where instead of people thinking around just small slices of the work, thinking about how what they do links together to ultimately deliver value to the customer. And adopting the Agile Scrum framework has been a very deliberate choice on our part to try to shift that focus and to focus on integrating aspects together to deliver to an end customer. And what we've seen is that through COVID and the teams being remote, it's forced them to find ways of working together and communicating. And one of the interesting things for me out of this has been that a lot of the tools that allow us to do that were already there. They were there when we were sat in the office. But actually, by forcing everyone to be working outside from home, has just brought those tools to life in a way that has fundamentally changed the way we work forever. I think even if we were back in the office, there would still be that same reliance on those new tools now, such as the value of them. And I'm sure you've found similar things in your own experiences. It's accelerated things like video-based training. Well, because we're doing the work over screens and remotely, why not just record it and make it available on wikis for people to access when they need it and new team members join the team. Another key thing is the agile approach is around trying to drive transparency. And I think transparency has become increasingly important when everyone's remote. Being able to see the work that others are doing and understand how that relates to what you're working on becomes important and key. You can't pick up so much of that contextual information just by being in the office. And the development tools that go alongside the Scrum framework have really allowed us to do that and have effectively forced that way of working upon us and given us the benefits of it. And also, by working through that, in those small teams that you get in a Scrum framework, it has driven that collaboration, which I think has a benefit of avoiding that sense of isolation that people can have when they are working remotely. And the other key advantage is that with a Scrum framework, all of the structures of meetings and ceremonies that are built in allow that regular contact of the team to be able to continue to work effectively together even though they're remote. I'm not saying it's perfect, but it's certainly helped us. And having had that Agile Scrum framework set up to an extent before lockdown and home working was definitely an advantage. Since then, we've then worked more on how do we organise the scaling of Scrum. So we have multiple Scrum teams operating, and the interactions and tiering of those Scrums becomes key to make sure that we all work collectively together in an effective way. Another side effect that we've seen, and this is maybe a little bit particular to our business, is we've operated across different geographical sites in the UK, and moving to remote working has effectively just removed those geographical barriers in a way that the past decade of attempts has been unable to achieve, which is a real positive thing to create a sense of that single team. And we also see that if we go further then to the global level, because of the business pressures that are evident at the moment, trying to collaborate more geographically across continents becomes key. So working with the US and across sectors, working with defence become key. And then our development environment. So we've seen an explosion in population of our wikis, people documenting the information, collaborating, changing it. We've seen breaking down of perceived barriers. Moving forward, we have expected engineers to have development boards, chat on their desks at home. Those kind of things in a large corporation often just don't happen. Yet this has caused us to question some of those fundamental barriers and just remove them. And then we've really found that having sprint reviews, constantly bringing us back together to review what's been achieved and plan our next steps, has been of key value for us. So we're looking to exploit these innovations in products and generate a return on investment. And so looking not just at civil markets with the Ultrafan geared turbofan, but also at defence markets with both the V280 in the US and with the Tempest fighter program in the UK. So whilst we're not at the end of our journey yet, we're definitely well on our way. And I'd say that the short-term outlook for our industry is quite uncertain, but we have to continue to innovate to ensure that we are match fit to face the challenges of the future and win. Thank you.
Thank you, Simon, for giving us a glimpse into the current threats faced by the aviation industry and the work going into modernising systems to propel it forward from here on out. Next up, we have Matt Jones, VP of Engineering and Chief Systems Architect at Wind River. In this role, Matt is working to advance safety-critical real-time Linux and cloud technologies with the aim to transform market segments ranging from aerospace and defence, automotive, industrial, medical and telecommunications. A long-standing active member of the Geneva Alliance, Matt is the current chairman, has previously served as its president and is currently head of product marketing for the Alliance. The Alliance is focused on infotainment and the connected car to power the next generation of mobility solutions. He is here with us today to present digital transformations, and disruptors in the future connected autonomous world. Over to you, Matt.
Thanks, Emma, for that introduction. So my name's Matt Jones, and I'm the VP at Wind River. Now, Wind River was founded in 1981 as an embedded tools and operating system company. As we've just heard, in aerospace and defense, they're really leading the way in many new technologies. We've been working in that area for almost 40 years, and we're undergoing the same transitioning to an intelligent systems platform company. But it's far from just aerospace and defense. Although the DoD in the US has this artificial intelligence strategic focus for aircraft, for land-based vehicles, we're looking the same for all of the autonomous cars that doubtlessly many of you will have seen on the news and documentaries, and some of you even in the roads. Now, I've been in these autonomous cars many times, and I can absolutely guarantee that the semi-autonomous features are here. And even the autonomous features will be with us in certain geographic locations very, very soon. But it's more than just the roads. We see machines such as the one on the screen, these factory robots. But they're not just factories that they're operating in. There's warehouses, there's dockyards. We're even starting to see them now in various medical facilities shuttling around for different supplies to the different wards. How is this artificial intelligence? How is that actually helping to create this future world of connected, intelligent, autonomous devices? Well, it's worth considering really what is artificial intelligence. So we talk a lot about artificial intelligence, and that's really defined as any technique that enables computers to mimic human intelligence, using logic, if-then rules, decision trees, and machine learning. And then as a subset of that, you have this machine learning, which again, the industry talks a huge amount about. And this is the obtuse statistical techniques that enable machines to improve tasks with experience. And then as a subset of that machine learning, you have this deep learning component. This is the algorithms that permit the software to train itself. But the challenge you have with any system based on deep learning, machine learning, artificial intelligence, is that it requires huge amounts of data. Data of what's happening in these systems that can be fed into the deep learning, machine learning, artificial intelligence platforms to generate algorithms. But when you're looking at this from the embedded domain, be it a plane, be it an autonomous car, you have to iterate around this algorithmic loop, generating more data with the past algorithms, processing and improving those, and then generating more data with those new algorithms. But what really does this iterative flow that you need in order to create machine learning, artificial intelligence algorithms, how does that work in what we would describe as an embedded environment, where you have safety critical features that typically have run on RTOS, but you're trying to use algorithms for AI, algorithms for sensor fusion that are more closely coupled to Linux in that non-safety critical environment? Well, we know that even the aerospace hotspots that you see in Boeings and Airbus around the world, they're moving to what we describe as a heterogeneous environment, where you don't have one operating system. You have almost the best of both worlds. You have that hard real-time, safety-critical real-time operating system and Linux by the side of it for all of those different algorithms. And this isn't just aerospace and defense. We see it hugely in industrial, with the TSN Ethernet networks, IIoT product as a service. We see it in telco with the NFVs and the various rack-mounted servers that you have, very much moving to this heterogeneous world. And within that heterogeneous world, you have a single, usually multi-core processor with a hypervisor on top. Now, on top of that, you can still have your safety-critical applications running on an RTOS. But then, alongside that, you can have your non-safety critical applications. A statistical model recognizing sensor data in the same way a human would recognize an object cannot be safety proven. And many of those algorithms were natively developed for Linux. It makes sense to adopt that open source, adopt that learning, and run that on Linux. but have them on the same processor, really taking advantage of the capabilities for that hardware and hypervisor to safely partition the software. If we think of some of the examples, robotic operating system 2, it's an architecture that uses DDS, that uses these various connection technologies between multiple ECUs, multiple electronic control units, multiple guest operating systems, all sitting on these hypervisors. ROS is natively coded for Linux in its first instantiation. Works well with AutoSAR and these different automotive components. But using a real-time operating system, the state machines, the safety cases can be rapidly redeployed to give you that hardened safety rated element with the goodness of the open source Linux. But as we said at the start, this is very much about the iteration. And it's not just about being able to create these algorithms. You need to be able to deploy these future autonomous algorithms rapidly to the targets, the embedded targets that could be anywhere in the system. In order to do that, you really want to embrace what we would describe as cloud-native applications. So decoupled applications that really don't particularly care about the hardware or the software platform that they're running on, that can scale very, very easily. In the same way as if you deployed a job into Microsoft Azure or Amazon AWS, you can demand more processing power, more storage instantaneously. And they do this via networks of connected servers. Now, that's not quite the same for that embedded environment, but when it comes to being able to use those cloud-native applications to generate the algorithms, that's exactly where the industry is going. When you have those algorithms, you have your software updates. In the same way as your Android or your iPhone, you need that concept of secure remote software updates to update any of the machines, any of the ECUs within your network. Now, there's a challenge between what we would consider a software update that comes from the Apple phone store, for all intents and purposes, an app coming down onto your platform, and the safety critical nature of an autonomous vehicle. And if you consider that safety critical nature of an autonomous system, it has to be fully protected. But now it's connected, it also has to be entirely cyber secure, including that entire chain of trust into the software that would be deployed on that device at a given point in time. And really that chain of trust is just one part of what we would describe as a DevSecOps lifecycle. Many of you will have heard of DevOps, development operations, how you can rapidly create software, usually in agile fashion, usually for continuous delivery or continuous deployment, but adding that security section into that development process. And when we talk about security, we're really looking at not only ensuring that the output of your development pipelines are secure, ultimately testing that to your best possible methods, ensuring there's no CVEs within that system, but also wrapping the DevSecOps environment with security to guarantee you understand exactly the provenance of all of the code that comes into it, the provenance of the build systems, the provenance of the output. It's absolutely critical that you have this traceability. And when we talk about the provenance, this would mean that you know exactly who committed what code, when and where, which containerized build services were potentially used in order to compile that code. And then that secure certificate-based signing of the output binary, even including the test cases to ensure that it was actually that binary that was tested before you even contemplate deploying that into a security critical or safety critical environment. Now, this isn't new news. Even the US Air Force published a paper by Nick Shalane last year saying, in the future, our software factory will be based on DevSecOps practices. It is absolutely critical in Nick's eyes, in our eyes, that security is of utmost importance in order to create these future autonomous safety critical systems. And in order to do that, you actually get some benefits. We talked at the very start about having this iterative cycle of collecting data, optimizing the algorithms, deploying those algorithms, collecting data. If you can have effectively a software factory, a set of software pipelines that minimize the downtime, minimize the distraction on every developer, removing the need for manual intervention, especially in repetitive tasks like code scanning or testing, you can improve the cycle time. Rather than iterating once a week, you may be able to iterate once an hour. If you can take in 40 times as many iterations, you're going to get that autonomous product to market far faster. To give you an example of what we've done at Wind River in order to do this, previously to build an entire Linux stack for a single board support package might take 2.5 hours. Now, if you're Wind River and you have a product based on Linux, it's critical that you remove that cycle time. We don't build for one board support package, we build for hundreds potentially. So we've worked on reducing that cycle time through cloud-native techniques to just 5 minutes. And you can do this using cloud-native techniques in parallel. So we're not building one version of Linux in 5 minutes, we're building all of them. So what could potentially have taken overnight build jobs, and people would go not for a coffee, but go for dinner, go for 8 hours sleep, come back to the office, they can now achieve whilst they're checking an email by the side of the system. Again, very much focused on reducing that cycle time. But it's not just about that compilation time. It's how can a developer interact with all of the code, all the scanning tools for security and code quality. How can they then build that? And those builds be automatically tested, potentially in digital twin simulation environments like CIMIX or QEMU, again at cloud scale. And then once it's past those gateways, automatically deployed. Maybe deployed to the test device on their desk, or the test device in their lab, or the fleet that you would have running around for test purposes in a tame environment. Or potentially even in the future, delivered, ready for deployment to update real vehicles, real autonomous systems in the field. Now, if we think about the study, we know from Tesla, who've been very vocal about this, that they've been collecting data on real customers and what their cars are doing in anonymized formats for a while, for years. Once they get that data from the customer, all of that is amalgamated, cross-correlated, so that they can start to recognize issues before they appear in the field. From that same usage data, that same analytics data, they try and repeat, but they've got access at the developer's desk to that data. They can make improvements to the system, push that out into their test fleets, and when ready, push that out into real users' vehicles. So what we're talking about here with aerospace and defense really leading into autonomy needing artificial intelligence almost mandating this pairing of the cloud with embedded real-time operating systems and embedded Linux systems, being able to be software updated remotely with development tool chains that very much focus on that entire lifespan of the development is real. You see it in every Tesla today. But the most important thing for our future digital lives is that it's not just about Teslas. This is about all of the medical providers, all of the industrial machinery providers, all of the autonomous aerospace, defense, and automotive players, because all of those spheres overlap. And it's our mission at Wind River to enable artificial intelligence on these security and safety critical platforms to be as easy to develop as anything ever has been, so that our customers, so that users of our open source projects can develop their applications, their intellectual property, the bits that matter to them, far faster than before. I've said many times before, nobody ever bought a car because of the operating system. You buy a car because of the features, the functions, the design. It's our mission to enable our customers to iterate the features, the functions far faster than they've ever done before. So with that, I'd very much like to thank you.
Thank you very much, Matt Jones, for giving us an insight into the future of safety-critical autonomous systems. And now, for our final speaker of the day, ahead of our panel session, we have Walid Negm, Chief Innovation Officer for the Altran Group, part of Capgemini. Walid is responsible for technology strategy and innovation and serves on the group's executive committee on technology and innovation. He brings 25 years of experience prior to Altran at Accenture, and also he has co-founded and been responsible for product development at various cybersecurity and mobile infrastructure startups. He holds a bachelor's and master's degree in computer engineering from Boston University and an MBA from the McDonough School of Business at Georgetown University. Therefore, his expertise is perfectly aligned to his presentation for today, titled How to Emerge Stronger and More Resilient from the COVID-19 Crisis.
Well, thanks for that. A quick note just about Altran. We are now part of the engineering, research, and development business of Capgemini. A bit of history, Altran was founded in 1982. One of our first projects was working on the Airbus A320. In April of this year, we tried to formulate a more coherent picture of what leading companies are doing to both stabilize themselves, but also figure out how they're going to emerge stronger from the crisis. And a key question we asked was, what does it mean to get out of this situation with much more resilience? I think a core message, which is not a surprise over the last 6 months for everybody, is that it's a good idea to take advantage of the situation and not waste it. Don't retreat. Instead, go on the offensive and get ready to break out while accumulating new strengths. So determination was certainly a key part of the mindset that most of these clients and leading companies had. Just let me share a quick analogy, given the image here on the screen. In motorsports, a safety or a pace car limits the speed on the track. Maybe there's a caution period because of obstruction or bad weather, and teams actually take advantage of this equalizer by making pit stops. They can refuel, change tires, and so on. And the pace car actually continues around the track. At some point, it's good to go, and unfortunately, some cars spend too much time in the pits. Others are much more efficient and gain position in racing. So it's really a strategy of staying forward. And so in business, including in research and development, companies that are emerging stronger out of the pits are evolving and adapting, maybe taking on new habits like work from home and institutionalizing them, or doubling down on their digital transformation. Whatever they're changing, when the flag goes up, they're out up front. So what does this moment look like? When we look at the economy, we see the impact of COVID has clearly not been evenly distributed from a sector perspective. The aerospace industry has seen significant challenges. And of course, technology and stay-at-home companies have done extremely well. Really, I think it's important to note some of the forces acting on recovery and regeneration of growth. We list 4 here. The first is that it took a lot of energy, and it takes a lot of energy to keep the pandemic at bay. Portfolio reviews focusing on cash, some of the basics around employee well-being being first order. The second force, certainly sovereign control of resources and capability. You think about 5G, the chips that go into everything, supply chain manufacturing, those are now been elevated as national security concerns. So very important part of the dynamic. The third, public sector, is a critical funding source now, especially for sustainability development. And then lastly, if you look at the pandemic, the pace of digital transformation has been put into high gear. And we're not talking about VPNs or collaboration tools, but really looking at end-to-end digitalization and how that is going to unfold. So, you're in a pandemic. Let's make things happen, whether it's creating something new. Let's step through here and see what companies are doing with clear-eyed determination. Okay, so what are leading companies doing to be difference makers and not waste this crisis or this moment? The first absolutely is dealing with COVID head-on as if it's a real-life situation for people and employees. And this really requires being empathetic. So when it comes to COVID-19, first things first is to take care of people. both physically and emotionally. When we're making products, when building products, engineering them, really it's about looking at the product for people and ways to do that while meeting the mission. The second is certainly production came to a screeching halt, and it was in large part due to breakdowns in the supply chain. COVID-19 revealed a lack of both agility and resilience in the supply chain. And this idea of digital continuity, being able to create a thread across design and specifications, requirements, the actual engineering work and manufacturing, really became a clear way forward to reduce friction, reduce inefficiency, and reduce costs. The third area, the third move to emerge stronger and more resilient is to take a look at decision making. Employees are pioneers of ideas, and they need to be empowered to develop those ideas and given the space to participate in a new way of making decisions. So there are several dynamics here, including work from home, which looks like it's going to be permanent to some degree, and other ways to reduce inefficiency like model-based systems engineering. Finally, radical ideas still very much matter. You want to deliver more than people ask for. Every industry is being updated. So a key question has become, how do you achieve scale in the innovation journey? How do you take ideas quickly to commercial outcomes? So let me step through each one of these and give you some examples. So the first move by companies that were real difference makers early in the pandemic was empathy. They saw what was happening and they did not hesitate to meet the employee but also the customer need head on. So I'll just give you a couple of examples on the bottom left-hand side. Whenever there's an emergency situation, something that's really important to take care of, the pioneers, I like to say, they take the corners out of the room. They remove all obstacles. And I think when it came to ventilators and innovating in ventilators, that happened. There's a variety of companies that tried to help. Cambridge Consultants, a company, is actually a Capgemini company, put together a very sophisticated emergency ventilator. It was designed and built at the request of the UK government for use in the treatment of COVID-19. What's interesting about it is, here we have a regulated product, it's safety critical, and it was designed in a little over 6 weeks. It was praised by ministries, clinicians, and healthcare authorities. So the idea that even in a regulated industry, these types of products that you can move at the speed of a startup, it takes about 5 or 6 years to develop a system to the levels of safety and clinical utility that are necessary for patient deployment. So I think that was very interesting, the way that played out in some of these very sophisticated products, this speed to market, but also not sacrificing on requirements. Another, I think, really great example of how to care deeply and engage with empathy in the automotive industry, certainly one of the consequences of the pandemic is hesitation to take public transit, at least in the early stages, but also how OEMs are looking to deploy new offers, new value propositions for customers, and actually taking a closer look at ways to sanitize the vehicle. Here on the top right-hand side is an example of the use of ultraviolet light, specifically UVC light, to disinfect the interiors. It's a pretty complicated engineering effort. You have to have the sensors and the devices that can disinfect the vehicle, but also how do you know whether or how do you assess the risk? How do you assess the disinfection rate? So it's a very multidisciplinary scenario, and automakers sort of maybe a little bit out of their comfort zone. And then the last example, I think it's, we all feel it in our personal lives in terms of healthcare and well-being. The life sciences sector certainly is looking out for our well-being, but now, I think they're facing the music in terms of doing it at a much faster clip. And I think COVID-19 is a catalyzing effect on taking a look at R&D costs and using different technology to benefit the population. Governments and tech companies are using AI tools to predict the spread. Symptom trackers. Certainly, we have telemedicine is crucial. So three examples of how you sit back and say, well, what does my customer need? How do I care deeply about their expectations? You can arrive at some pretty impressive outcomes. So the second move, major move, I think that most companies that leading forward had to take was restructure or take a look at restructuring their supply chain. The crisis did reveal in some industries that there was a fatal flaw in the resilience of global supply chains, between factory lockdowns and restarting them, transportation disruptions. The crisis highlighted geopolitical tensions and trade restrictions, etc. So I think that there's a big lesson here in terms of the resilience in both manufacturing and supply chains. One way to get that resilience better is to orchestrate the different phases of design, production, and supply, all the way to manufacturing and even distribution, to orchestrate that better. And there's been many terms used to describe that orchestration. One of them that's picked up is this idea of digital continuity, or this thread that weaves itself through the organization and outside of the organization. And so here's actually three examples that if we could weave a digital thread through these important activities to increase resilience, you could really change the dynamics of the supply chain. And the first one on the top left here is exception tracking. When you make a change to a part in the design phase, you have to communicate that change to component suppliers and take that into consideration in the change management process. And of course, in aerospace and some other industries, changing components is a very serious affair. It requires a new round of testing, safety testing, government approvals. So I think this, in design mock-ups, faster handling of resolutions, and being able to spot exceptions for better decision-making and coordination with suppliers is really important. Another could have potentially standalone activity that a lot of industry are pursuing is just better supply chain risk management. So if you want to regionalize your manufacturing and accelerate efforts to create supply chain networks at home and local to the customer, you're going to have to replace potentially one supplier with another, and the risk profile ends up changing. So putting in place dashboards, very detailed and granular decision support systems that ranks your supplier based upon key performance metrics, but also actually do that in an operational sense, right, in real time. This idea of identification and qualification of your suppliers can take months to do, but how you do it in an extremely rapid pace. And then the third area of opportunity, again, that can be done standalone, is looking at first article inspection. Again, this idea of inspecting a part when it arrives from a supplier is really important, typically supported by paper, and it's really hard to replace. So you get a part, and as part of the production process, and you have to go back and forth to make sure that it meets the specifications, and sometimes gets sent to an inspection agency. So if there's any deviation, that has to be remediated. So each of those three sort of topics are really important in design, manufacturing, production. And it's something that companies are doing, but how about stitching that all together? So if you're in the design phase and you spot a potential problem in the fit and the purpose of a part, you're able to reevaluate your suppliers and then attach a risk score to them, but also be able to then finally take that part and during inspection, digitize that process of inspection and communication with the supplier. So do maybe more of an open manufacturing process. So in digital continuity brings transparency, it brings flow and increased efficiencies. It's a really important focus area for a lot of design and engineering companies right now. Okay, so on to the third move. And that's really to take a look and update the decision-making paradigm. With COVID, it became clear that proximity of talent is no longer that important. If teams are working remotely, then what's important is the flow of information between them and to make it intuitive and efficient. Capgemini, permanent offices, some cases now will become temporary, and there will be places for employees to physically gather together, and it's maybe not mandatory anymore to go to the office. So that's a real change in habits. There'll be a transition to new rituals and also new tools to collaborate. So here's what I've run through we're going through with a lot of our clients, and three ways of working that are getting a lot of prominent attention. The first is certainly agile by default is the way to go in research and development. And we know the benefits of agile software development, moving to faster and iterative work, promoting collaboration. In regulated industries, of course, the way to do agile is to ensure that you have precision and objectivity of requirements. You can't just use in agile what's called user stories. They're too high level. They're missing precision. And an important part of getting that precision is model-based systems engineering tooling. So the product team can rapidly capture all the assumptions and dependencies, and then conduct what's called things like behavior analysis and trade-offs, etc. So, if we give you an example here that poses a little bit more challenge for model-based systems engineering and agile development is multi-core processor architectures. It's not fully adopted in avionics, but it is an important topic. Other industries are looking at other approaches when we know that Moore's law has reached sort of a limit. In case of multi-core processor architectures, how do you express the problem statement to now you're going to be dealing with machine learning engineers? Maybe they're putting together a computer vision algorithm. How do you define the requirements in the context for interference and contention between the hardware team and the software team? And how do you generate the right edge conditions to exercise that hardware? Again, certainly model-based systems engineering is an important part of the solution, but there's other approaches that have to be included, like robust allocation and scheduling of resources, online measurements and monitoring. And Altran is part of a research program in the UK called High Class that's applying model-based systems engineering and looking at it in the context of avionics systems, specifically looking at hardware resources and how resources are shared between cores. So again, agile is important. You need model-based systems engineering. You need innovation on that to deal with certain situations. Another way the decision-making paradigm is changing is through simulation. Simulations make the next decision better. Of course, simulations are being used in all industries in different ways, and they offer engineers access to events in a very safe and controlled environment. Physics simulations can be used to understand aerodynamics, etc. Right? Now, in the automotive industry, an example I wanted to share, ideally you want to design the entire vehicle virtually, including the assembly line, but all the supply activities, and kind of see how everything lays out. But if you take just one part of the automotive pipeline, which is testing and validation, that's a really important place where the economics of vehicle development is changing. When you fast forward to a number of years into the future, where there's more and more software in the car, whether it's for what's called level 2 or level 3 assisted driving systems or advanced assisted driving systems, the vehicle itself is going to be more software than hardware. And in order to test these vehicles, you can drive them around. It takes about 200 million kilometers to prove the reliability of an autonomous vehicle, especially for accident avoidance scenarios. Or, you can rely on the acquisition of ground truth or synthetic ground truth using simulation. I think the idea of using large data centers and automating the generation of traffic scenarios and complex edge conditions is really, really important for changing the decision-making paradigm and working with products that would need this type of rigor and validation. Another example of changing the decision-making paradigm, of course, is we know that pictures tell 1,000 words. Well, how about 3D pictures? How about 4D reconstruction of the world, including time? So there are many ways to talk about reconstruction of the real world and the benefits. One term that's being used, of course, is digital twin, where you capture, model, analyze, and simulate the real world. Right? So this idea of making decisions through a reconstruction of a product that is actually out there in the field, whether it's an industrial product, a subsystem, or a component, and be able to look at that process in part and understand its performance, gaining a lot of prominence. A couple of examples, certainly just simply looking at 3D data instead of creating new paper manuals. Just an error-free approach to do operations, quality control, and training. We were involved in just recently a pretty significant project where digital twins were used to improve the performance of thousands of individual turbines, wind turbine installations for power generation. So this is a way to just take a look at whether in fact the wind turbine is performing as expected or not, and of course to get ahead of any onset of failure. Okay. So just a couple of examples, regardless of the industry sector, telecommunications, automotive, aerospace, really twinning the real thing and getting an understanding of its performance characteristics using AI is really, really important. So let me just come to the last sort of move. We talk about the way that leading companies are managing through these uncertain times. One of the experiences that COVID has amplified is this dilemma around innovation, right? Innovation is coming up with a new idea, a new process, a new business model, but how do you accelerate the adoption of that idea? And one of the key lessons, I think, is figuring out how the organization is going to scale ideas. We have an interesting paper around scaling innovation that walks through some recommendations. I just wanted to highlight three that I think are really important for us as pioneers of ideas and thinking through how to improve processes and introduce new product development. And the first one is focusing with intensity. Where you place your bets is really, really important. And if you're in this space, high integrity systems, maybe you do want to look at open source and domain specific architectures, even in the midst of the pandemic, because the role of the processor and distributed architectures are really going to be important. Edge compute is going to be important. In some cases, 5G is maybe going to be less relevant, in the aircraft or in the car, but more relevant in the factory floor. So clearly, focusing with intensity, with a credible roadmap based on commitments and accountability, I think is a really important part of scaling innovation. The second, call it lesson is, treating scaling as its own discipline within innovation, whether innovation is centralized within your organization or decentralized. The idea of being able to team up with the business and push out into the commercial arena ideas in a repeatable way is important. I like to use the pharmaceutical industry because they have moved at a much faster speed in vaccine development, hopefully including all the safety and the rigor, of course. But rather than looking at vaccine development in years and years, they're looking at months and trying to cut the red tape, but also expedite the process through virtual clinical trials and other ideas. And then lastly, one of the lessons here is not to, in the middle of a crisis, not to completely shut down in terms of doing more and going beyond. I would say industries are being updated, and the pace of society is changing, cultures are changing. So I think the COVID pandemic has certainly highlighted the need to keep up with what's next, whether it's zero emission in aerospace or other sustainability programs. Well, that's it. I come to end to this session, and hopefully we shared some insights with you. And I'll pass it along to the next speaker.
Thank you, Walid, for providing those tangible examples illustrating resilience at this time and for emphasizing the need to continue scaling up innovation and find ways to continue pushing those new and innovative ideas out there. Note for everybody that the slides for all of the presentations are now available in PDF in the resource widget at the bottom of your screen. You will just need to refresh to gain access. This brings us nicely onto our panel session now, in which I'll be asking our three speakers questions, which will give us some further insight into their lessons learnt and how the challenges they have highlighted in high integrity digital systems innovations can be resolved. We have already received a number of questions and therefore won't have time to take any more that come in live from now. But please do keep submitting them, highlighting who you'd like to answer them, as our speakers have very kindly offered to respond to them offline after the event. So straight into question number one. COVID-19 has had a transformative impact on how we all work day to day in the software industry, the way we connect, interact, team dynamics, access to resources, and so on. From experience in your own organizations, what are the lessons you've learned from changes so far, and how do you see things changing as we move forward? Simon, we'll come to you first on this one. You did mention in your presentation a few elements of this, such as specific tools to facilitate effective communication. Can you expand on that and tell us more about how you see this changing at Rolls-Royce?
Yes, certainly. So certainly the move from the office to working remotely has made a big difference to the way in which we work and interact together. One of those tangible things straight away is as soon as you want to talk, not having to find a meeting, which has definitely been a big boon. And ironically, we've found that punctuality around things that we organise has actually improved through the changes that we've made, which is not something I would have necessarily seen. And the ability to get hold of people and interact with people has actually improved and got easier. One of the things I observed fairly early on is that the tools to allow us to collaborate and work together digitally were there all along within our organisation, but there was no real push to adopt them and take the benefits they gave us until it was forced upon us with COVID and all working remotely. Certainly, I expect, like most places, some bits have worked better than others. We've had a plethora of different environments that we've communicated and collaborated in. There's a certain amount of just finding out what works for each team and the flexibility to get on and do that. We've definitely found that having a good agile development environment that really allows teams and individuals to collaborate. But I think one of the key elements there is the transparency. So when you're in the office, being able to see what everyone's doing is quite easy. When you're remote, having that insight is much harder. And I think the development environment that makes that much more transparent is really key, along with sort of good visuals and dashboards to provide that information and insight to allow people to have a common understanding for working together. Clearly, the communication aspect is very important within any environment where you've got teams working together to develop something. And the frequent communication, informal and formal, through a framework has been fundamental, as you'd expect. We're social animals, and that communication is vital. Sometimes having events where people are really grouped together around a common problem, the little virtual hackathons, mini sprints that we've run, they seem to bring people together in a way that sort of substitutes for you might have achieved sometimes within the office. One thing we have noticed sort of more recently, as we've kind of changed things around as a result of the way the organisation is evolving, is that where you're making changes to teams, bringing new people in, it's much harder to develop some of those personal and social bonds that are are so key to having good, free and open communication between people, and that's certainly something that we are working on. I think the other thing I'd kind of just quickly highlight is the people being able to contribute to a body of knowledge, so populating wikis and video recording, little training and how-tos they're doing. Those kind of things have been quite key in terms of trying to share information effectively between people and between teams.
I think in terms of tooling, for example, it allows us to do things like have a virtual version of a conference like HAS. So yeah, it's definitely pushing us to be able to do those new things that you're talking about. Matt, we'll now come to you. What have you learned in terms of the new day-to-day, and how do you see this moving forward at Wind River?
So we're definitely in a new normal, and even with the fantastic news we're having on a daily basis of the vaccine, we don't believe from a software-centric company such as Wind River that we'll ever go back to the day-to-day time in the office. And we've had some challenges, as you can imagine, over the last 6 or 7 months since the infamous March the 17th when we closed the office. The biggest challenge we initially had was purely the quality of the connectivity we had in some of the areas. We have offices in Costa Rica, we have offices in Canada, we have multiple offices across the world. Not everybody, when working from home, could get access to high quality broadband that was adequate for Zoom conferences, especially when some of our staff effectively had other people sharing that connection. Multiple breadwinners, if I can put it like that, working from home, and children being educated. So we actively had to work with those people, work with telcos to ensure that our staff had the connection. But I guess looking forward to when we can have the option of working in the office, kind of the biggest identified concern that we have so far is that we turned into a video conference culture, a Zoom culture, where in a way everyone has their own little box. Everybody has the same level of interaction with other people through their little video window and being able to talk on the conference call. Our biggest concern is what happens when you go back to a situation where you have maybe 4 people sat around a table with access to all of their senses, all of the body language, everything else, and then you have 2 people remote on Zoom. And for that reason, in a way, we're contemplating already how we can train people to be very aware of those that are still remote in their interactions and ensure that we don't end up with a driver that means we end up with everybody back in an office because there's a feeling you have to be in the office in order to be heard or listened to or really any of the above. Does that make sense?
Yeah, it does. And I think that the equality almost that you get when you're all in that square on the Zoom call or whatever provider you're using, that's interesting. And certainly the fact that you're now working on training to have that dynamic approach of remote and in-office working. So Walid, in terms of your emphasis on resilience in the day-to-day for software engineering teams at Altran or Capgemini, how does this play out currently, and how do you see this moving forward?
Yeah, so thanks a lot. I agree with all the speakers. I think a key lesson right up front, of course, we're all in this together, but a key lesson is that during this crisis, it's clear that sort of a new chessboard is playing out in different industries, and the companies just can't let up on staying competitive, like having that that will and deliberation, to figure out what's wrong and also get ready to compete aggressively. A very important lesson. Certainly, the fact that we all have the confidence to work remotely and get work done, where proximity doesn't matter. For us, I think one of the lessons, which is a hindsight is 2020, is when you enter a crisis strong, you are more resilient during it. So we were fortunate enough to have adopted Agile. We stood up a centralized platform for code sharing and for builds. We were able to reduce cycle times on certain projects earlier, but then we also had the methodologies to onboard new projects much quicker. So I think that's an important lesson. taking that forward, I suppose new thinking and ideas in virtual development is going to be super important. Clearly, there's significant investments in more collaborative design and product lifecycle management tooling that's cloud-based. But thinking about it in much more detail for specific industry sectors like automotive or aerospace, there are innovations that should be taken forward, again, to remain competitive and to continue to reduce costs and get more efficient. So I think that for us there are great ideas out there, and we have to really take them to and dig deeper into their conclusion.
And I think that kind of leads quite nicely into our second question. So how do you feel trade associations or influential R&D funding bodies or associations can help stimulate innovation during this period? And Walid, I'll stick with you on this next question. You use the UK Civil Avionics R&D program High Class as an example, as one that Altran is involved with, and as AdaCore are, as well as many other key players in the UK. But this is just a tiny part of the large innovation potential out there. How do you feel these associations in the UK and globally can help here to really stimulate that innovation?
So I think there's especially in the current uncertainty, there's a push for our clients, and we're an design and engineering partner. It's like the largest design engineering partner in the world, serving aerospace, automotive, and life sciences, other industry sectors. All these clients are looking for ways to carry on their innovation moves, and for the most impacted sectors, they're convinced that they have to move forward, but cash is usually focused on critical operations. So they're looking for models to share investments and risk, even of course sharing the benefits. So subsidy programs are super important in certain geographies. They're really a significant way to achieve even sovereignty goals. Remain driven by the future and still drive innovation. So I think public-private partnerships are another really important approach. Again, I think in France there's some significant investments behind 5G and telco sector and hydrogen, which is an important ecology stream. I think it's about $100 billion in overall sort of a relaunch plan. So I think when you look at the different existential threats for some of our industry clients, whether it's data-driven R&D or electrification and hydrogen, everybody's going hydrogen crazy, or autonomous driving. I think there's a great merit in pursuing both R&D funding bodies as well as joint ventures and creative business models to kind of keep forward, especially given the cash crunch that a lot of these industries are facing.
And that collaboration is something that you, Simon, also you touched upon in your presentation, with specifically pointing out the value of building upon those existing ideas and working collaboratively on them. Would you be able to kind of expand on that in your experience at Rolls-Royce?
Yes, certainly. So the taking ideas that are already out there and using them in your context and your environment, I think, is a really quick way of accelerating. But you need to have those interactions, and certainly the where you get involved with partnerships through R&D funding, etc., you get exposed to different ways of thinking and different ideas that you can then incorporate into solutions that you're trying to develop within your own context. I think even before the COVID crisis, R&D funding played a massive part in stimulating innovation, certainly within our industry. And there's no question in my mind that where the aviation sector has really struggled through changes, obviously, in the market from COVID, that R&D funding will continue to be very important in maintaining focus within the business on innovation and driving it forward. And I think that's absolutely vital that happens in order to come out strong and able to take advantage of new market opportunities.
And Matt, do you share the same the same feelings as Walid and Simon, or do you have kind of a different approach to the question of how funding bodies can help to stimulate this innovation?
I've got similar thoughts. I agree with everything that Simon and Walid have said so far. And I can only really comment from our personal experience that throughout COVID, as an international company, very similar to Simon's and Walid, actually the funding bodies are there, but we've also found a greater willingness to collaborate remotely. So we've signed up maybe 20, 30 different partnerships to help us support our existing and potential customers over the last 6 to 9 months. And that seems like more than we've ever done in any of the years previously. And some of this may be due to the fact, again, that we've got this remote work culture. If you're working with people remotely, it seems easier than it was before. There was always a reluctance to maybe collaborate because you weren't in the same office and you didn't give the same amount of time to people that you didn't see. But now, again, we have that great Zoom. Other providers are available, Leveler. The extent and the depth of the collaboration seem to be easier than before. In some ways, I would always encourage the funding bodies to be more responsive and faster. There's still these long processes to go through to get funding compared with just building a partnership, a collaboration. So I think there's always more that can be done, but it seems to be good so far.
Mm-hmm. And we'll stick with you on the next question. The sudden increase in remote working and distributed teams has highlighted the need for efficient practices and tools such as continuous integration, continuous delivery that work seamlessly and at scale. What do you see as the forthcoming trends in the way that we build software that will help our industry cope with continued pressures, and are those trends here to stay?
So answering the last bit first, these trends are here to stay. As I commented previously about our experience working remotely over the last 9 months, we had these challenges with connectivity. We have the challenges with security, given that people may want to VPN in, use their own devices more than they've ever done before. We're definitely opening up the number of threats that you have to a software development. Now, Winter is focused on safe and secure software. We always have been with our safety-critical real-time operating systems. This doesn't just mean that that operating system, VxWorks, has to be safe and secure. It means all of the code, all of the tools. We have to understand exactly which software engineer committed what line of code. Was it built with certified compilers? Do we understand the build system? And that gets exponentially harder where you don't have everybody, if I can put it like this, locked in an office. At the same point, COVID has affected efficiencies. Dogs barking, babies crying, all of the things that we've heard over the last 6 months, all of the challenges we probably experienced working from home does affect the productivity. So we're really looking at how we can use automation and even autonomous and artificial intelligence overlays into that continuous integration of software. But before you kind of get to those artificial intelligence overlays on that DevSecOps pipeline, it's absolutely essential that you have the building blocks in place to absolutely be able to certify that this is really the person I think it is committing the code. This is really the infrastructure I think it is building the product for test or for release. So securing that infrastructure has been a huge focus of ours, probably for 18 months, but we've absolutely been able to test it through the COVID crisis. Once we have that, it's then, just like any artificial intelligence system, you're looking for those efficiencies, and you do that by collecting data, changing the way certain of the pipelines work, the pipelines that would create, build all of the different chunks of software that we release. And what we discovered straight away that the efficiencies that you can gain aren't necessarily there if you fix the pipeline. So what it really came down to for our software factory is ensuring that some of those elements that we would have seen as fixed previously can be more flexible, almost giving more control, more power to the developer sat at the desk. But with that control and that power for all of these different configuration options, ease of use and developer experience really came to the forefront. How can we enable a developer not to have to command line into a server, not to have to exchange huge amounts of files over their slow broadband connection to their house because they don't have a 1 or 10 gigabit network link to their desk anymore? And how could we almost go to browser-based development where everything you need in that software development lifecycle is available in a Chrome browser window? So over the last 9 months, we've really built that out to such an extent that we've seen performance improvements, efficiency improvements in our internal team. And to such an extent where we've been talking to some of our existing partners and customers about this, and they're actually interested in how they could learn from what we've had to do internally. And conversely, we've been learning from what their needs are. What are they trying to accomplish with the tools, the software tools? How do they develop applications on some of our products? So we're really turning this into an ecosystem. Hopefully that answers the question.
Yeah, I think it does. And also, I think that potentially you mentioned this in your presentation as well. There's a certain amount of traceability that comes with all of that as well. It's like increasing the authority and the power of the developers, but ensuring that there's traceability so other people can see exactly what they're doing and have software assurances from a security point of view.
That's right. And that traceability, and that traceability actually helps with the collaboration, being able to see what everybody else is doing from a software assurance perspective. Almost encourages the teams to work together in ways that they wouldn't have done before. People are developing just on a single desktop. All of the traces, all of the logs are not necessarily visible to the hundreds of other developers on that project. But once you start moving to this cloud-native environments where all of the logs are instantly searchable, instantly available, it makes a big difference.
Mm. And so for you, Simon, what do you see as the forthcoming trends in the way that you're building software at Rolls-Royce and the continued pressures that you're seeing? And do you think that these trends are here to stay, or do you think that they're going to change as soon as we're out of the current situation that we're in?
No, I absolutely think these trends are here to stay, and I think some of these trends were there before, and as I said, this has accelerated their use and adoption. So continuous integration, clearly a key part, but the beauty of something like that is just how scalable it is. You can start off small and then grow it and get increasing gains from it, and that's certainly something that we're seeing. You know, as soon as you start to get those continuous integration pipelines in place, get some value from them by having your data and your your underlying information managed in models. You can start to link in your simulation, your automation, your reuse, all supported through that continuous integration. And clearly, none of this works necessarily right first time out the box, and it's a constant learning and evolving cycle that you're going through. I think one of the things that we're seeing as well is that there's various different pieces of information that we need to link together in order to fully define our product and fully define and create all of the evidence we need to be able to certify our products. And working on how all those bits interact together and the environment that we produce them in is being key. So how do you create a seamless environment to manage all of that information has been certainly a journey that we're on.
Mm. And so Walid, at Altran Capgemini, what do you see in terms of these trends after and following the increase in remote working and distributed teams to ensure the safe and secure software practices that you've maintained?
So again, agile practice in DevOps. So that makes it much easier to mix and match people and skills. If you have a centralized software release management tool or platform, you can do automated testing, faster cycle times, less errors. So everything that gentleman before mentioned, super important. I think the idea of virtual validation, of virtual verification validation is significant. Here the idea is not to replace physical real-world tests, but maybe whether you're self-auditing or you're going under certification, by an agency is to do the testing as early as possible, as fully as possible, as accurately as possible. So there's certainly, as the ratio of software content in all these things keeps rising, you're going to have to demonstrate how these software functions perform, and if they perform as intended to. So there's a lot of innovation there. I think some were mentioned earlier around, how do you certify code that's running on multi-processors, make sure that these functions that have had hard timing requirements really do perform the way that they're intended to. But in general, the verification and validation process is undergoing a rethink. In that vein and related to virtual development, digital mock-ups, they cut costs by eliminating physical prototypes. I was just reading that GM is looking at 18-month cycle timeline to develop their new electric vehicle models. The 2022 GMC Hummer EV had no scale models or clay busts. The democratization of simulation, I think that's a really important trend in software development. We're looking at data-driven models that are part of the experience. So whether it's a finite element machine or multi-physics solvers, there's just a lot going on in open source and gaming engines and cloud. And then I think a common core here is just simpler, more intuitive approaches that are very, very collaborative. So specialized teams, whether they're in aerodynamics or structural design, et cetera, that are working together nicely. So a lot of interesting things. I also agree with the idea of when you are building simulations and models to capture the fullest picture of a product from its initial design files, et cetera, there has to be a way to manage all that data, all the material data, even the resulting sensor measurements over time and the state of the product, whether it's location or dynamic behavior. So there has to be a way to manage all that data in one place. That's a really interesting space as well, which I think companies are going to invest in. I guess it's referred to as digital twins.
Yeah, and in terms of that, of the verification and the validation, an increase in autonomous systems underpinned by advances in AI is a common theme in your presentations and a common theme in the area of high integrity software as it stands at the moment. What do you see as the particular challenges and potential responses to deploying AI in critical systems, for example, in the area of verification and validation?
Yeah, there was a similar question online. I think it's related to how do you trust an algorithm that's been trained using evidence that's incomplete or that there's a black box. So this, I think, really nicely falls into the area of trust for sure, right? So high accuracy of AI models by itself doesn't translate into trust. There's also the consequences of failure. So there are frameworks to think about deploying trusted AI, including assurance, where the model, right, which you're going to train, for example, and maybe you're going to use multi-physics, but you're going to train somehow is using data that is proven to be accurate, complete, from a trusted source. There's also certainly topics around explainability, making sure that it is not a black box, or at least if you're using deep learning, that the weights that you've used somehow are explainable using counterfactual evidence. So I think in general, there's a lot of thinking around trustworthy AI. We're looking at data quality as an important barometer for achieving trustworthiness. Certainly data completeness in safety critical or critical safety environments is key. So if you're only transmitting or recording data intermittently, are you capturing the full perception of the environment the timeliness of the data, the adequacy of the data, do you have an adequate number of samples? So all of these are metrics that you can use to determine whether the data that you're training your models are in fact, avoid the whole garbage in, garbage out problem statement. So I think in general, there's that topic. There's I think a really interesting conversation around multiprocessor certifying software on AI silicon and multiprocessor. So if you are going to be using autonomous systems that depend on different types of chipsets, there's real benefits in high-powered silicon that do things very specifically, manage space, milliwatt hour of power, et cetera. But then you have to really look carefully at the architecture and identify possible contention challenges and hard timing requirements. So I think that's another really interesting area, is how do you certify code running on these multi-domain architectures that you're trying to use to achieve these outcomes, these machine learning outcomes. So those are interesting topics. The last topic I'd say is, you really don't necessarily want to depend on one approach to reason. Sometimes you need a rule, you need an optimizer of some sort, just a classic optimizer. And then other times you do need evidence and real-world observations. But, in general, when you look at somebody who's been working on the shop floor for 25 years, and then you want somebody who's 25 years old to do the same thing, there's a lot of knowledge that's and intuition that you need to capture from the seasoned individual. And how do organizations deal with that is a really interesting area, sometimes called as knowledge graphs, trying to avoid tunnel vision in connecting silos of information. So if you have, the health departments capturing data on accidents, and you have, a semi-autonomous vehicle that's driving blindly using its deep learning algorithm, and then there's other risk management domains of knowledge. What happens when you connect all of these things together? Can you reason better about an intersection, for example, right? Instead of just following one decision tree or another. So I think knowledge management in general, especially in virtual engineering, is going to be a pretty exciting space.
And especially from a cross-domain kind of point of view, as you pointed out, with healthcare as well in there, especially at the moment. And Matt, I would like to get your input on this question as well.
Yeah, thank you. And it's actually interesting the way Walid finished that with the example of the intersection, where can you get a better approach to autonomy in a vehicular sense if those cars can communicate? And it almost comes back to that challenge of partnerships and that challenge of collaboration. So what I'm seeing at the moment, especially in automotive and in some of the other industries, because autonomy is seen as a real differentiator with a lot of intellectual property to be generated and ultimately monetized by those companies, there's not those deep levels of collaboration that you need in order to ensure car-to-car communication, where every OEM's car talks to every other OEM's car, which is obviously needed when it comes to that junction example. And so in some ways, I think the biggest challenge that we're facing in car-to-car communication and smart city collaboration is the insurance that companies feel that they can come to the table, that they can collaborate, that they can have standards relating to communication. And if you think about the companies that we're talking about, the BMWs, the Jaguar Land Rovers, all of these different teams, they're all using the same silicon underneath. They're all using the same operating systems. They're all using the same RF waves, be it DSRC or cellular V2X. How can we get them to start talking the same language? I often get asked, well, why don't we just legislate for it? Why don't we write laws? Let's think about how quickly we need this move, how quickly we need the API to potentially evolve as we learn exactly what is needed for car-to-car communication in this rapidly moving sphere of autonomous vehicles. Legislation has to be carefully written so that it doesn't lock us into technologies that potentially we don't want anymore. If we think of how fast 5G has come to market in real terms, we think about some of the test beds that are now being funded for 6G, forecast by 2030. And then you think about the lifespan of a set of traffic lights, of a typical vehicle on the roads, where they're 5, maybe 10 years, depending on if it's infrastructure or the mobile infrastructure that is a car. How do we solve that problem? And ultimately, I think it comes down to accepting and understanding where the intellectual property is, and accepting that we do need alliances and we do need standardization of some of these pieces. And those alliances and those standards really need to evolve as quickly as the technology, not be an afterthought, even though that this is an emerging sphere in terms of autonomy onto the roads of the UK, Europe, and beyond.
Okay, thanks very much for that. I think Emma's phone line's just dropped out, so I'm just going to pick up there while she's dialing back in. In fact, I think we're close to the end now. Thanks very much for those answers, Matt and Walid. We've just got time to move on to that final question. And I'd like to bring Simon back in here, if possible. Simon, we're just wondering if you can provide us a vision of how you see the business environment evolving over the next few years, for example, in terms of partnerships, joint ventures, etc., that may help our industry, the software industry, respond to the current challenges that we have.
Yes, thank you. So the answer is sort of more around the aerospace sector, which I'm working within, and it's no secret what a challenging business environment that has been in response to COVID. And the reality is it's going to continue to be for the next several years. Certainly, there's predictions that we're not sort of really looking to pick back up to previous levels until 2024 at the earliest. You know, the kind of thing that none of us really saw coming at the back end of last year. So what we're seeing is sort of changing of size and shape of businesses in response to that dramatic change in the market size, and that's a necessary adjustment that needs to go through, albeit painful. But there's an underlying desire and strong intent to build back stronger. And you know, when we think about this building back stronger, we're looking at those long-term trends that will remain long beyond COVID, those around electrification, those around digitalization, and being ready really to embrace the opportunities that they bring is key to us. We look at when we talk around partnership programs, so a bit of a mixed picture here, I think. So we've seen some partnership programs cancelled. So we had partnerships around things like the EFAN-X, which is a hybrid electric demonstrator on a BA-146 aircraft with a 2 megawatt electric motor driving a fan. So that was collaboration with Siemens, with Airbus. And you know, at the start of the COVID crisis with financial pressures, that partnership program got cancelled. So there's some certainly downward pressures against that. But then if I look forward, you know, I see more opportunities for partnerships and work. I think some of those will come out of where there is increased funding as well. So I'm thinking around the defence sector, which tends to be quite buoyant in response to some of the challenges that the civil has been seeing. And I think that remains a fertile ground for partnerships and collaboration going forward.
Thank you, Simon. That is just about all we've got time for today. We ran through those questions pretty quickly. I would like to say a big thank you to all of you speakers. Thank you so much for your time, and we will forward you any of the unanswered questions so you can follow up with those with the attendees. And thank you to everybody who has joined us for today. We really hope that this provided you with the opportunity to hear about current challenges in the high integrity software community. One of the reasons why we started this conference quite a few years ago now was to create a platform for this that we believe wasn't there already. And next time we hope that you'll join us again, either at physical or at a virtual event, whatever the powers above have in store for us. So do check out the conference website in the future for more information on that, or follow us on Twitter at HIS_conf. This entire event will also be available on demand indefinitely if you would like to go back and listen to any parts in particular or share with your colleagues, and you will receive an email within 48 hours with a link to access this. You can also submit further questions through this platform, and you will also receive a survey if you'd like to provide us with some feedback. So thank you again to our speakers and for you for joining us, and we hope to see you again at another HIS event.